Hi. This is the second lecture in the Piping Fundamental video series. Today we will discuss some definitions and terminologies that every piping engineer must know. The first one is pretty obvious. What is pipe? Pipe is a pressure-tight cylinder used to convey fluids. Pipe materials are normally from metals, plastics or glass fibers. The first property we shall notice, it is a pressure-tight, so if it is open, we name it a channel, and it is not in our scope today. The second note is pipe should be cylindrical. Consequently, if it is rectangular, we call it conduit, and it has another usage. The second definition, what is piping system? Piping is an assembly of piping components used to convey and distribute, mix and discharge, control through valves, meter fluid flows. Piping also includes pipe supporting elements but does not include support structures, such as building frames, foundations, or any equipment. And this is a group of geometrical definitions for the pipe, such as wall thickness, outside diameter, inside diameter, nominal pipe size, which is a designator of pipe size based on American standard. It indicates standard pipe size. For example, nominal pipe size of 2 inches indicates a pipe whose outside diameter is 2/3 inches. The nominal pipe size of 12 inches and smaller, pipe has outside diameter greater than the size designator. The nominal pipe size of 14 inches and larger, pipe has outside diameter equal to the size designator. Pipe schedule is another designator based on American standards ASME B36.10, B36.19. Pipe schedule number is a dimensionless number that is related to pipe wall thickness. At the beginning, the American Standards Association (ANSI) standardized the dimensions of steel pipes. At that time, only a small selection of wall thicknesses were in use: standard weight (STD), extra strong (XS), and double extra strong (XXS). All large nominal pipe sizes of 8 to 36 inches of XS have 1/2 inch wall thickness. As these three sizes did not fit all applications, schedule numbers were added later as a convenient designation: 5, 10, 40, 60, 80, 120, 140, and 160. So how schedule number is calculated? It is referred to the approximate value of equation 1000 P over S, where P is the service pressure and S is the allowable stress, both expressed in pounds per square inch. These tables extracted from ASME B36.10, it shows pipe wall thickness related to each schedule and diameter. It also shows that pipe outside diameter is greater than nominal pipe size to 12 inch. Although pressure vessel is not considered a piping system component, we have to review some definitions related to pressure vessel as they are closely related to piping. Pressure vessel is a container designed to hold gases or liquids at a pressure substantially different from the ambient pressure. In some countries, you have to build any pressure vessel above 6 inch in size and contains pressure above 1 atmospheric pressure according to code. Codes dealing with design and construction of pressure vessels, such as ASME Boiler and Pressure Vessel Code Section 8, or the British Standard PD 5500. Pressure vessel consists of shell, contains the pressure and consists of plates that have been welded together with an axis. Horizontal drums use shells with a cylindrical shape. Head, this is what closes off the end of a pressure vessel. Manways are the openings or access points to a pressure vessel. The number and the size of manway opening vary from application to application, usually ranging from 6 to 36 inches in diameter. Saddle have the vital role to support the pressure vessel and to maintain its stability. Nozzle is an opening in the pressure vessel through which fluid enters or exits. In general, nozzles project from the pressure vessel's surface and ends with a means of joining, flanged or welded, to connect piping or equipment. In the next slides we shall hold comparisons between piping and other systems commonly confused with piping. Pipes versus tubes. Piping usually interface with major equipment like pumps, heaters, boilers and tanks. It usually concerns with fluid flow from, to, equipment. Tubes are small diameter, max of 1/2 inch, conforming to standards other than those used in piping. Tubes used to transmit fluid pressure and usually interface with control valves and instruments. Pipes versus pipeline. As we stated previously, piping is assembles of components that are used to distribute, meter and control fluid flow. Pipeline is pretty similar, but it concerns mainly with fluid transportation, and it extends behind customers' metering station. For more clarification, this schematic shows the natural gas production process. This process starts with offshore production platform, onshore process plant, metering and pressure reduction stations, gas storage and tank farm, LNG and export terminals. Pipelines are concerned with connection between these plants. Piping is within the battery limits of each plant. We could ask, where is precisely the battery limit between piping and pipeline? Pipeline extends between the last valve, flanger insulation joint of a plant, and the first valve, flanger insulation joint of next plant. These definitions are according to the DNV and API standards. Let's show this concept on the piping diagram of offshore platform. This is the insulation joint, upstream is piping system, and downstream is the pipeline. Another example for the same production platform on this piping arrangement. On the top seat there are equipment connected with piping systems till the latest flange, valve or insulation joint. Then, pipeline starts afterwards.